Welcome to the 11th and final lesson in measurement for my CSEC mathematics series. This lesson is going to be about scale diagrams, and you will learn what a scale diagram is, why it is necessary, and how it can be used to determine distances and areas. Now, a scale diagram is a representation where the dimensions are adjusted by a consistent ratio, allowing a smaller or larger version to accurately reflect the proportions of the original. This is used in fields such as engineering, architecture, and geography to depict large structures or areas on a more manageable scale while maintaining true dimensional relationships. One great example of this that you can actually feel and touch is model cars. Some model cars have 1 to 20 size ratios, meaning that it is 20 times smaller than the original car, and hobbyists tend to build these car models on their own. Now let's look at the first example. If a map has a scale of 1 to 100,000, which means 1 centimeter represents 100,000 centimeters in real life, then represent a line of 5 kilometers on the map. In this example, the scale is 1 to 100,000, meaning that each centimeter on the map represents 100,000 centimeters in real life. Since 100,000 centimeters is equal to 1 kilometer, we can represent larger distances accurately by using this ratio. To represent a distance of 5 kilometers, we'd simply divide 5 kilometers by the 1 kilometer represented by each centimeter on the map, resulting in 5 centimeters. Therefore, a line drawn 5 centimeters long on the map would correspond to a real-life distance of 5 kilometers. When the scale is represented as a ratio without units, it's important to remember that we can choose any consistent unit, such as centimeters or inches, as the ratio only specifies relative sizes. Let's draw this in a diagram so you can see what I'm talking about. All right, so to summarize what we learned previously from the example, depending on what you need, you can either multiply or divide by the scale factor to find the actual distance or the drawing distance. On a map with a scale of 1 to 100,000, the distance between two towns is 5 centimeters. What is the actual distance? Well, from the previous example, by multiplying the map distance by the scale factor and converting units, we can find that the actual distance between the two towns is 5 kilometers. Let's draw this out to show it. Let's look at another example. A room is 8 meters long in reality. On a floor plan drawn to a scale of 1 to 200, what is the length of the room on the drawing? Finally, we'll look at areas. When dealing with areas, the scale factor is squared because area is a two-dimensional measurement. Once you do this, the process remains the same. Drawing area times area scale factor will give you the actual area, and drawing area is equal to the actual area divided by the area scale factor. Let's look at this example. On a map with a scale of 1 to 50,000, a lake covers an area of 2 centimeters squared. What is the actual area? And let's look at this final example. Number 5, a rectangular park is drawn with dimensions 4 centimeters by 6 centimeters on a drawing scale with a scale of 1 to 500. Find the actual perimeter and area of the park. And that's it. In this lesson, we explored the use of scale diagrams to represent structures that are either too large or too small to be depicted at their actual size, which is useful in fields like engineering, architecture, and geography. We discussed how linear scales are applied to determine distances accurately on these diagrams. Additionally, we examined the process of deriving an area scale factor from a linear scale factor and demonstrated its application in calculating real-world areas from maps. Thank you for joining me in this lesson on scale diagrams, and in the next lesson, we'll practice questions related to measurement. Feel free to leave any questions or comments below, and don't forget to join the Google Classroom for the series resources. See you in the next lesson. Bye.